Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 5 from lesson 6-3 in the SavvasRealize Algebra 1 textbook. The goal of this video is to examine exponential growth and decay and compare them. So it says that Rich is comparing the cost of maintaining his car with the depreciating value of the car. When will the cost and the value be the same? I'll be honest, I didn't like the picture that was in the book, so I took some liberties and replaced it with my own. So you might see a different car. Anyway, so the first thing we need to talk about is what the heck is depreciating value? What is that? What does that even mean, y'all? So you guys have probably heard your parents talk and seen that they've talked maybe about something called like the Kelley Blue Book value of a car. I don't know how many times you guys have seen your parents purchase a car, but that's the Kelley Blue Book is the depreciated value. So let's talk about what depreciation is and where it comes from real quick. So when you buy a car, the moment that you drive it off the lot, it is suddenly worth less. Just immediately. Without you really having done anything. You just get in your car, drive off, and as soon as your back wheel is off that lot, your car is suddenly worth a less amount because it is suddenly used. So that part kind of gets confusing for kids, but let's talk about the depreciation further. So the more that you drive a car, the more that you use a car, the less good that it runs, right? Like, I don't know, my 1995 Ford Escort that I first started in is not going to be as good as my 2016 Chevy Sonic. Right? It's not going to happen. There's a 20-year difference between those. Right? And why doesn't that Escort drive as good? Well, I mean, after time, the parts start to kind of wear out a little bit. You know, some of them you can replace, right? I could replace tires whose treads get weak. I could do oil changes as much as I want. But, you know, I mean, eventually that engine, right, starts to kind of wear down. The plastic siding starts to crack off, right? My windshield gets chips and dings. Okay, so over time, the car stops running as well. And so because of that, because you'd have to pay more money to fix it, it's worth less and less and less. So that's the concept of depreciation. And so the best way that we talk about depreciation is how much of that car per year is it getting worth less of an amount. Okay, so in this case, Rich is saying that his car is getting 15% suckier, essentially, per year. And so that's why he's talking about that as his depreciation. Now, as time goes on, it costs more and more money to keep these cars on the road. Okay, so like when my car was brand spanking new, right, my maintenance was, oh, I need an oil change. Woohoo! Well, eventually it turns into, oh, I need an oil change and I need to replace my tires. And then after that, it's, well, my transmission went out, so now I have to pay for a transmission. So the maintenance cost every year starts to become more and more because more stuff starts to break. More stuff starts to wear out. And that makes sense. So now here's what he's trying to think about, right? He's trying to think about the value of his car, so how much his car is actually worth, versus the amount that it costs to keep his car on the road. The instant that it starts costing more to keep your car active than your car is worth, that's when you need a new car because you want your value to be worth more than your maintenance cost. Alright, so hopefully that made sense. So now let's actually do some calculations, huh? So the equation that I'm using, notice that this does not talk about any type of compounding. So the equation that I'm going to use is the one that says that the amount is equal to your starting amount or your initial amount times 1 plus that rate to the x, where a is your principal or starting value, and your r is that rate. So when I go to do this, my value, or my final amount here, starts at $20,000, so that's the number that I put for A, and then 1, and because I'm depreciating, I'm decreasing here, I'm going to put 1 minus this rate. And remember, that rate has got to be like a decimal, not a percentage. And I probably should have called that an f of x instead of an a. Sorry, I'm mixing up my formulas a little bit. That might be what you've seen better. There we go. So now, if I clean up that parentheses a little bit, this is the formula for his depreciation. So now let's look at his maintenance cost. So his maintenance is starting at $500, and then it's increasing. It costs more and more to fix his car. So this is going to be a plus instead of a minus. That 28% is 0.28. So there we are. So there's our two formulas. And what we're going to do is we're going to take that into Desmos. Okay? So what I'm doing is I'm using my snipping tool so that I can save this screen and see it in a second. And let's go to our Desmos. So my first formula was talking about his depreciation. So I'm starting at $20,000 and I'm losing 15% of it per year. And if I zoom really far, you can kind of see that, right? Maybe I should change my x-axis a little bit on my graph. Let's go from -10 to like 100. And my y-axis, I'm going to go from -10 to 21,000. There we go. So that's a nicer view, right? You can see the general lifespan of that car, although no one's going to have that car for 100 years. Okay, so here we are with his depreciation. So now let's bring in his maintenance. I'm going to call it g of x instead of f of x, or so I don't confuse this thing. And so you could see where things start to kind of crisscross, right? So his maintenance cost is going up very quickly. And so right there on that graph is where you could see the number of years. Okay, so just pasting that graph onto my thing here so we could look at it. So what this is saying, remember your x value is your number of years, is that at about 9 years, the cost of keeping the car on the road and the value of the car are both about $4 grand. So at this point in time is when he should sell his car, because then shortly after that, the cost of keeping it on the road is more than the actual value of the car. So he'd be losing money by driving that car. Actually, I shouldn't say losing money, I should say losing equity. And so this part that I'm going to tell you here, this is actually a social justice part, and it is not anything to do with Savvas, okay? So this is not Savvas's opinion, this is my own, okay? And it's kind of me warning you as a student or as a person. So when you are, I'm going to say it, when you're poor, I grew up poor, okay? I have never owned a brand new vehicle ever, because I can't afford it. I'm a teacher. I don't even make that much money. So what happens is when you're poor, you tend to buy used, right? Like my first car, I literally paid $800 for it. Okay? My next car, I literally paid like 8 grand for it. Okay, so I'm buying used vehicles. And so because I can't afford the new vehicles, I'm buying used vehicles, which are like further over here down the line, right? Oh, I bought a 5-year-old car. I'm right here. And so what that does is that gives me less time before I start losing equity on that vehicle. And so people that are more wealthy that can afford to buy the new vehicle, they get all this time in order to enjoy that vehicle and have it be as a benefit towards their equity, towards their value. Okay? And so what ends up happening is a lot of people go and they sell their car when it reaches about this. When you start having to pay a bunch to repair your car. And so they'll sell their car to a dealership when it's at this point. And then people that can't afford, fancy cars will buy it at this point. And then they're just sinking a bunch of money into that car. And so being in a situation like this where it costs more money to keep your car on the road than your car is worth means that every time you have to repair that car, you're essentially just kind of like throwing that money away because it's not benefiting the car, it's not keeping it to where it's going to be worth more. And so that's kind of an economics idea here and where different car lots kind of value things. So that's kind of an interesting thought, one that you should consider as you are car shopping, essentially. That's why it's important to look at the mileage on cars as well. The try it here wants us to talk about using tables on the graphing calculator. I'm just going to mention it real quick. The table on a graphing calculator tells you your values of x and your values of y, right? So it gives you all these ordered pairs. So if you can look at the table of values on these two graphs and you can find the one that has that same y value, that will tell you the intersection point that you're looking for and how to solve the problem. Anyway, so there we have it. That is exponential growth and decay. Until next time.